Today we're going to learn about a property called albedo and how it affects climate change. Albedo is a measurement of how reflective a surface is. When sunlight hits the Earth's surface, it can either be reflected or absorbed by that surface. How much is reflected or how much is absorbed all depends on the albedo of that surface. Some surfaces, like this snowfield, have a high albedo. That means they reflect a lot of sunlight, while other surfaces, like this farm field, have a lower albedo, so they don't reflect as much of the sunlight, and instead they absorb it. Here's a clip from MIT that explains a little more about how albedo works.
If you've ever walked barefoot on pavement in the summer sun, you probably know how burning hot it can get. This phenomenon, as it turns out, is more than just a nuisance. It actually has a dramatic impact on our daily lives, from the Earth's climate to human health. We refer to it as albedo. Here's how it works. Solar radiation constantly enters the atmosphere, where it is either absorbed or reflected by the Earth's surface. While the energy that is absorbed stays and warms the Earth, the reflected energy travels back to the atmosphere, some of which is returned to space. Albedo is a measure of this reflected radiation. The higher the albedo, the more energy is reflected, and the lower the albedo, the more energy is absorbed. We can actually measure the magnitude of albedo, in large part due to color. Lighter colored surfaces reflect more radiation, which we perceive as light, and have a higher albedo. On the other hand, darker surfaces absorb more light and have a lower albedo. So what impact does albedo have on our lives? When sunlight hits a city, dark man-made surfaces on pavements and roofs absorb this energy and begin to heat up. This warms surrounding areas throughout the day and long after the sun sets. This phenomenon, by which cities experience increased temperatures relative to their rural surroundings, is known as the urban heat island effect. To compensate for the increased temperatures caused by this effect, cities are forced to consume more energy to cool overheated buildings, which can accelerate climate change and introduce harmful pollutants into the air. So at first glance, the albedo of urban surfaces seems pretty destructive, but that isn't always the case. We can actually use albedo to our advantage. By modifying the reflectivity of surfaces around us, we can directly impact the relationship between the amount of energy absorbed by the planet and the amount leaving it. This has the potential to significantly mitigate the impacts of climate change and the urban heat island effect. According to our research at the MIT Concrete Sustainability Hub, if all urban and rural roads in the continental United States were converted to higher albedo pavements, savings would equal 20 million tons in CO2 emissions per year. This would be like removing nearly 4.4 million cars from the road. We also found that a moderate increase in the albedo of pavements only in U.S. urban areas led to a 41% decrease in heat waves across those areas. As heat waves lead to increased mortality, increasing albedo will not only mitigate climate change and the urban heat island effect, it can also save lives. As climate change accelerates over the coming decades, we will need to think creatively to alleviate the worst of its effects. Playing with the surface albedo of our cities and highways may prove to be one such creative strategy. To learn more about albedo and albedo research being conducted at MIT, go to cshub.mit.edu/pavements/albedo.
Write this down in your notes. Albedo is the ability of a surface to reflect light. High albedo reflects more, low albedo reflects less. Now remember, when insolation or sunlight reaches Earth's surface, two things can happen to it depending on what that surface is like. First, it can be reflected back up. Surfaces that are good reflectors are going to have these qualities. They're going to be lighter in color, and they're going to have a smoother surface. So, snow and ice have those qualities, so they make good reflectors. If that sunlight isn't reflected, it's absorbed. Surfaces that are good absorbers are going to have these properties. They'll be darker in color and have a rougher surface. A great example of this is pavement in the middle of summer. As I'm sure you all know, asphalt gets very hot, dark color, rough surface, and if you try walking on it in your bare feet, you'll burn them. Now, Earth, of course, has darker and lighter colored surfaces, which is good because the darker surfaces allow us to absorb some heat, which keeps us warm, the lighter surfaces reflect some of that light so we don't get too warm. At least that's how it's supposed to work. The problem we're having today is that because of the increased greenhouse effect, the planet's getting warmer. That's causing more ice to melt, which is decreasing the planet's albedo. So instead of reflecting more of that sunlight, we're actually absorbing more of it, which is just making it even warmer, and something called a positive feedback loop begins.
In order to understand the Earth's climate, it's critical we understand how warm the planet is, how its temperature changes over time, and what factors can force those changes. The sun is the Earth's primary source of heat, constantly bathing us with solar radiation. The land surface, cloud cover, and our atmosphere help determine how much of that heat is reflected and how much is retained.
How that changes over time is really critical, because in a climate system that's in equilibrium, those two should really balance. And if they do, then the temperatures will remain relatively constant with time. Now, when you add greenhouse gases such as carbon dioxide, methane, you change that radiation balance at the top of the atmosphere. You reduce the amount of outgoing radiation, and so that imbalance means more energy is in the system. Part of it goes into the ocean, as it's stored in the ocean, and part of it goes into actually warming the Earth.
Because of climate change, the global temperature has been increasing. As a result, large amounts of sea ice is melting. As the ice reduces, the total surface area of the Arctic ice shrinks. This is causing a positive albedo feedback loop by reducing the total albedo or reflectiveness of the Arctic regions. The word albedo refers to the proportion of radiation or light that is reflected rather than absorbed by a surface. As a rule of thumb, brighter surfaces have a higher albedo and reflect more light, whereas darker surfaces have a lower albedo and absorb more light. The more solar radiation the surface reflects, the less it heats up compared to surfaces with lower albedos. Positive feedback loops occur almost everywhere, from cattle becoming startled, to population growth, to even recursive computer programs. In this case, the Arctic ice melts, which causes a reduction in surface area, which reduces the total albedo of the Earth, causing the global temperature to rise, which then in turn returns back to more ice melting. Although it has the word positive in it, the positive feedback loop actually has a negative effect on us and the global climate.
If nothing is done to make up for the climate change and the loss of Arctic ice, the feedback loop is predicted to continue to run until the ice is non-existent.